Okay, so this is the last section or last part of section one. We're going to be talking about function notation today, which is something you guys should have done in Algebra 1, Algebra 2. I know a lot of you have probably forgotten all that, so we'll go through a refresher here, but we're going to do a lot more with it probably than what you guys did in Algebra 1. So first thing I want to do is compare it. Basically, function notation can always be compared to what we call XY notation. So when you have an equation and your variables are just x and y, that's what we would generally call XY notation. Okay. Then function notation is more or less, it does the same thing, but it's a little bit more specific. It's a little bit more detailed, which is really, really useful when you have multiple different inputs and multiple different outputs. So function notation, basically what it does is it replaces the y, the output side of our function, with f of x.
Oh, we've done this before.
Okay. Yeah, I'm sure you guys have seen it. A lot of times it confuses people. It's really not that difficult once you get the hang of it. First thing I want to go over, that's usually pronounced f of x. It means f is a function of x. Basically means x is your input or the domain. Okay. Now, this is not like two separate things. It's not, the parentheses don't mean multiplication there. Basically, this is always going to be one chunk. This entire thing, the f of x, is like the y. Okay? So that whole f of x part is like what the y used to be. So this is our function notation. Okay, so the directions, like what you'll have on your homework, is to find each function value. And when we're talking about function value here, we're basically referring to the output, okay? So it's going to give you an input that you're going to plug in, evaluate it, and get the function value or the output part of it, okay? So that's going to look something like this. It'll give you a function. So we've got x squared minus 2x plus 8. Okay, so this is really just like a general equation. This would be the same as if it said y equals x squared minus 2x plus 8. So that's just your general function or equation. And then it's going to give you an input. And the nice thing about function notation is it allows you to deal with like multiple different inputs and still keep them specific. So it's going to give you something like f of 5. Okay. So this is basically saying f when the input is 5. So this is what it will give you. You're going to replace all the x's over here with 5 and then evaluate it, work it out. Okay. So this would be 5 squared minus 2 times 5 plus 8. And here you don't really need to, but I almost always put parentheses around my input because when you have a negative number, it does become important a lot of times, and it just makes it easy to see right away when I'm looking at, hey, my input is right there and there. It just kind of helps separate it. So I think that's helpful. And then we just work it out, evaluate it. So 5 squared is 25 minus 10 plus 8. So we have 15 plus 8, which is 23. Now, I'll tell you, since this side of my equation has not changed, you can actually just leave it like that and circle the 23. That's what I do a lot. Or you can bring that down and say, hey, f of 5. So my function, when the input is 5, is 23. The function value is our output right there. Everybody good there so far? Okay. So the nice thing about function notation again though is it shows us what the input was right there with it. Because now we're going to do a part B where we're going to have a different one. And I'm going to have to erase this for the video. So for part B, we're going to do f of negative 3d. You can actually have a variable in your input. So we're doing the exact same thing. This is my input, so I'm going to plug it in everywhere for x, put parentheses around it. It's especially important now because we have a negative. So I'm putting negative 3d, and that entire thing is squared. That whole parentheses is like what the x was. Okay? Minus 2 parentheses negative 3d plus 8. Okay. Then we just simplify it as far as we can. So negative 3 squared is 9d squared plus 6d plus 8. No, because they have different exponents.
Oh, okay.
So that's good there. We've got our. You just simplify it as far as you can, and then that's it. Okay. So number 2, we've got a different function now. G of x will work. We'll use that just the exact same as f of x, just a different variable. And first, we're going to find g of negative 3a plus 8. Okay, so our input now is negative 3a plus 8. So we have to plug that in everywhere for the x. And be really, really careful here with this x squared. Now, I know that looks really messy, but we can simplify it a lot, which is what we're going to do. So I'm just going to put the equals, and I'm not going to mess with the left side there. So the first thing, I'm just going to deal with the numerator. So we need to distribute. So that's going to be negative 6a plus 16. But then we also have plus 3, so I'm just going to go ahead and put the plus 19. Is everybody okay with that?
Yeah.
Okay. Just simplify the whole numerator at once. Okay, now the denominator here, especially for this part right here, we need to be really, really careful. Anytime I have a binomial squared, so I have something in parentheses with a plus or a minus sign, okay, to where it's 2 separate terms, you have to be really, really careful. Does anybody remember how to do that? Yeah, so typically what students want to do is just square both of them, but technically something squared actually means times itself. Now I'm going to show you guys there's a pattern for this that makes it a little bit easier, so you don't have to write this down, but just follow along for a second. Anytime you have a binomial, and A and B are just generic here, okay? Anytime it's squared, okay? that actually means, let me see if I can focus that because there's a bad glare. Okay. Anytime it's squared, that actually means times itself. Okay. Everybody good with that? Well, and when you have that, you have to FOIL. Okay. Which means first, outer, inner, last. Now, you could do that here. You could write this all out and FOIL it, but there's actually a pattern to it that I want to show you. Makes it a little bit easier. So anytime you have a plus b times a plus b, well, your first is going to be a squared, right? Your outer is ab, but then the inner is going to be the exact same thing. Is everybody good with that? And then the last is b squared. Well, then you have those combine. You combine like terms. And so that is the generic pattern that holds true all the time. So you can use that here and actually not have to write it out. So basically, if you look at this, if you know in your head, I have to FOIL it, right? The first is just going to be that times itself. So 9a squared. Everybody good with that?
Yeah.
Okay. Then the outer would be the negative 3a times the 8.
Which is negative 24.
But then you are going to have the exact same thing again, so it doubles. Yes. That's the outer and the inner sort of already combined. And then the last is just going to be that times itself. Is everybody good with that? If you want to write it out times itself, you can absolutely do that. Okay. And then we have to catch the rest of this here. So this is going to be plus 6a minus 16. And then we have that plus 1. And then we just have to go through and combine like terms. There's no other a squared, but we have negative 48a and 6a. So our last step here should be negative 48a plus 6a,
42A.
negative 42a.
Plus 45.
64 minus 16 is going to be 48 plus 1, should be 49, right?
Yeah, I accidentally put a 3 right there.
All right, this is going to be what we call a piecewise function. It's going to look a little bit different. All right, so this looks kind of strange. It's not really that bad. Basically, it's not like 3 functions kind of just all jumbled together, which is kind of what it looks like at first. It's only one at a time depending on what the input is. So if you read this, f of x is negative 5x squared if x is less than negative 6. So if it's that chunk of the number line, it's that function. If x is between negative 6 and 12, though, then it's this function. Okay? And then if x is greater than 12, well, then it's this function. So it's basically one of those 3 different functions depending on what the input is. Okay? And I actually think it actually shows up a lot in things like businesses, or the easiest way to think about it is like taxes. And I don't know the tax code very well, or one that keeps changing. But think about it, like you don't get, your taxes are not calculated the same for everybody, okay? If you earn less than a certain amount, then your tax is a certain percentage on certain things. And then if you make above a certain amount, or like within a certain range, you have a different tax percentage, right? And then if you make above another certain amount, you get charged. So it's like different depending on what the amount of money you make is. Okay. It'd be the same thing here. If x is like -8, well, you would plug it in here and get your value. It would be this type of function. If it's between -6 and 12, then it's this function, and if it's greater than 12, then it's this function. Okay? So what we're going to do is find f of -7, first off. Okay? So since our input is -7, that's got to be this first function, if x is less than -6. So we're going to plug it in here. Be sure and put parentheses around it, because when you square a negative number, if you do it on your calculator and you don't use parentheses, it messes it up. So -7 squared is 49. -5 times 49 is -245.
Okay. Wait. Oh, never mind.
Okay. And for part B, we're going to do f of, let's do f of 12. Okay. So if my input is 12, well, which one of these three is it going to go in?
This way, middle.
The second one, where it's or equal to 12, can't go in the third one. So I'm plugging my input into here for x. So I've got
12 squared. Plus 12. Plus 1.
Okay, that's 144. Which is
157.
157. Okay. And the nice thing about function notation, guys, because it may look a little bit more complicated at first, but where it comes in nice is when you have multiple different inputs like this, it would get really confusing to have y equals -245 and then right after it have y equals 157, right? The function notation shows you specifically what input goes with that answer. Okay, so that's why function notation is nice. All right, that is it for today.